This is Unit 4, Video 1. In this unit, we will be talking about compounds and their properties and how they form. Now, remember, a compound is two or more elements. We'll say different elements, two or more different elements, chemically combined. So, the most famous compound is H2O. There you have oxygen and hydrogen, and they have been chemically combined. Probably the second most famous one is sodium chloride, NaCl, table salt. Again, you have two different elements chemically combined. And we'll talk about properties of these compounds. Now, typically we say there are two types of compounds. The first type is ionic, and hopefully you hear the word ion in there. The second type is covalent, and the word co means something among them, between them. Now, anytime you do bonding, remember that valence electrons are the ones that are being involved. So we define valence electrons as outside electrons. You'll notice that here, these right here are the valence electrons. There are two more inner electrons. These are not involved in bonding. It's just the outside, the valence electrons, that are involved in bonding between two atoms when they bond. And what happens is the valence electrons are pulled in and they have an attraction for the nucleus of the opposite atom. But it's the valence electrons, the outside electrons, that are going to be interacting. So ionic compounds are composed of ions, positive ions called cations and negative ions called anions, which would make sense. And these are formed by a transfer of electrons. Now this usually happens from a metal to a nonmetal. So these will involve a metal from the left side of the periodic table and a nonmetal from the right. So here you see this happening with sodium, which is a metal, and you'll notice that sodium is transferring an electron to chlorine, which is a nonmetal. And as that happens, sodium loses an electron, becomes positive. Chlorine gains an electron, becomes negative. And then between these two, the positive and the negatives, now there's an attraction, and these two essentially bond together. And usually for us, it'll always be the case that ionic compounds contain a metal and they contain a nonmetal. So you can recognize ionic compounds from that fact. Some properties of ionic compounds. These ionic compounds are solids at room temperature. In fact, even above room temperature, they are solid. So you'll never see a liquid ionic compound, for example. And they have high melting points because it's difficult to melt them because they're solids. They'll have a high melting point and then obviously a high boiling point because this is a measure of how strong the attractions between the ions are. In fact, in here you have essentially ions that are attracted to each other, and that attraction between those ions is very strong. So that positive and that negative is very, very strong, and that's why it's tough to melt them, it's tough to boil them. Now these conduct electricity if dissolved. If they're dissolved, they'll conduct electricity, but they won't if it's in solid form. So if you try to see whether this chunk of salt conducts, you'd have to put it in water. Water is able to actually split up the ions and then allow them to conduct. And that's the idea. Alright, now covalent compounds, the other class of compounds, are formed when there is a sharing of electrons. Not a transfer, but a sharing of electrons. And this usually happens between nonmetals. So a case in point would be carbon, which is a nonmetal, and hydrogen, which is also a nonmetal. Now what they're doing is carbon has 4 valence electrons. These are the valence electrons of carbon. And then hydrogen has just 1 valence electron. So this would be the valence electron of hydrogen. And notice that they're sharing. Carbon is sharing 1, hydrogen is sharing 1. So this is actually a sharing of electrons. Same thing is happening between this hydrogen and the carbon, this hydrogen and the carbon, and this one as well. So the sharing of electrons is what we define as a covalent compound. Now you could share you could share a pair of electrons. Here we have 2. This would be 1 bond. If you share 2 pairs of electrons, this would be a double bond. So you can say 2 bonds. And then you could have 6 for the total. You could have a triple bond. But there's no such thing as a quadruple bond. Triple bonds are the highest types of bonds. Some properties of covalent compounds is they are usually liquids or gases at room temperature. It's possible for them to be a solid, but if they are a solid, it'll be easy to melt them. So these have low melting points and also low boiling points. And they do not conduct electricity, whether dissolved or undissolved. So here we have two examples. Here's just a liquid, some sort of liquid, and here is the liquid acetone, which is a covalent compound. Acetone does not conduct electricity. It's already a liquid. It's easy to boil it. It's a classic example of a covalent compound. Incidentally, acetone is made of the elements carbon, oxygen, and hydrogen. These are the three elements that go into making acetone. Notice they're all nonmetals. Alright, so here we have a picture of both of these compounds. So NaCl represents the ionic compound. And you'll notice that in ionic compounds you have essentially these spheres represent positive and negative charges. So the green sphere actually represents the negative side, negative charge, a blue sphere, a positive charge. And the blue spheres are small because when you lose electrons you become small, when you gain electrons you become big. So you'll see in an ionic compound it's essentially a collection, an ordered collection of these. And you can in fact see oftentimes this ordered collection on our level, on the macroscopic level. So this is an ionic compound and what it looks like. Covalent compounds then, here we have some water. So H2O is a famous covalent compound. And what you see is you see individual water molecules and collection of water molecules. So each one of these water molecules is a covalent compound, is the idea. And at our level, you'll see, notice this is a liquid, whereas ionic compound is a solid. Now a molecule, let's put all these up, a molecule is a neutral group of atoms held by covalent bonds. So whenever you're referring to a molecule, you have to be referring to a covalent compound. Down here I say there is no such thing as an ionic molecule. Ionic molecules do not exist. Ionic molecules, or rather covalent molecules exist, but ionic molecules do not. So here are some covalent molecular formulas. So H2O is a famous one. Here is another one, NH3. This is called ammonia. And then this is just oxygen, but it's a molecule. Now you'll notice that this oxygen right here is not a compound because there's only one type of element. However, it's a molecule still because those two atoms are grouped together. They're sharing electrons. So ionic compounds actually have what's called a lattice. So this collection of positives and negatives here is called a lattice. Ionic compounds are not called molecules. Very important distinction. And here is the details of how an ionic crystal lattice works. Essentially, a crystal lattice, which is an ionic compound kind of broken up, it could actually be taken apart. You can actually split them apart and put them back together. So here you show them on the left side split apart into individual ions. These would be negative ions, these would be the positive ions, and then they'll come back together. When they come back together, these are still the negative, these are the positive. So that's why there's no such thing as a separate molecule. With a molecule, you'd have to have, say, 3 of these connected together. That would be a separate molecule. If these were molecules, you'd see that these guys would be a separate unit. But that is not how it works with ionic compounds. So hopefully that makes sense with this picture. Now there are special types of covalent compounds. We call these acids. So we're going to spend a little time defining them and work with them. An acid then is any compound that begins with hydrogen for us. This will be the definition for us. An example is hydrochloric acid. Notice H is what the acid begins with. Now this is because acids produce or release these H's, and they actually release H pluses, which are ions, hydrogen ions. When these are released, then the acid does its work. It's essentially, if it dissolves metals or if it reacts with another compound, what it's doing is it's doing it through the H plus. H plus is a really interesting ion because it's made from hydrogen. Now if you remember, hydrogen has only one proton in it and its mass is 101, which means that proton is the only one that goes into the mass. So in other words, you have no neutron in hydrogen. It's actually the only element that does not have a neutron, which means what you've got with H plus ions are actually protons. So this guy right here is actually a proton. So acids actually release protons. So sometimes they call them proton donors for that reason. Another example of an acid is sulfuric acid, and this acid has 2 hydrogens. So this one can actually donate 2 hydrogens. Sulfuric acid is very dangerous. It's feared by most chemists. It's a healthy fear we have for sulfuric acid. And because it produces an ion, here it says this makes acids conduct electricity. Just like ionic compounds, acids conduct electricity. So they're almost like a split between covalent and ionics. They're like a mix between covalent and ionics. But they are covalent because they're made of nonmetals. Right, so let's finish up with an example. And here it says identify these compounds as ionic or covalent. And it's as easy as consulting the periodic table and taking a look at whether the element is a metal or a nonmetal. So for the first one we have chlorine and oxygen. So chlorine is right here, oxygen is up here. Notice they're both to the right of the staircase. So they're both nonmetals. So because these are nonmetals, that would be covalent. This is a covalent compound. They are sharing electrons. The two chlorines and the oxygen are sharing electrons. And the compound would look like this. If you were to draw them, it would actually look like this. Here's how they'll share the electrons. And it'll have this bent-like structure to it. Alright, Ki contains potassium and iodine. So potassium's down here, and then iodine is out here, which means that we have something from the left side, something from the right side of the periodic table. This is a metal and a nonmetal. Which means we have an ionic compound. Good. And then the last one is HBr. Now we have hydrogen, which is up here. Here's hydrogen. And then bromine, which is right above iodine. So we still have two nonmetals. And so this would be covalent. So we have two nonmetals. So this is covalent, but it's a special type of covalent compound. It's actually an acid. So the best answer is actually this is an acid. And because acids conduct electricity, they are a little bit like ionic compounds because that hydrogen they produce conducts electricity. They're technically not ionic because they have low melting points, but they can do what ionics do, and that is conduct electricity. Alright, try one on your own, and this wraps up a short lesson for us in Unit 4.